This is the third video in our 6-part series on how the 2-transistor flasher circuit works. If you haven't watched any of these videos yet, go back to part 1. In the next video, we're going to look at the inner workings of the 2-transistor flasher circuit. In this video, we're going to look at some more basic principles, which we first saw in the previous video. This is a tight wired breadboard layout. So you'll see it's quite clear and easy to see. This is also an example of a relatively tight wired circuit on a breadboard. This is not a tight wired circuit. It can be quite confusing and difficult to see where the wires go. And it's pretty busy. Not in the next episode, but in the episode after that, we'll have a look at breadboarding techniques and how you can clean up your breadboard wiring to make it more reliable, but also easier to see where things might have gone wrong if things went wrong. We're going to place the transistor over here on the circuit board with the flat face of the transistor facing that way. This transistor is a 2N3904, which is an NPN general purpose transistor. The switching action of the transistor is controlled by the base. Let's connect the middle pin of the transistor, which is the base of the transistor. We're connecting to the bottom end of the pull up switch. We've got a 10 kilo ohm pull down resistor over there, and we've got a 1 kilo ohm pull up resistor over here. But this 1 kilo ohm pull up resistor is not in the circuit until we pull up with the pull up switch. Now the pull up switch completes the circuit to the base, and then there's a current limiting resistor here to protect this LED. If we replace the pull up resistor above the press switch, when we click like this, we're not seeing the LED illuminate, and if I keep my finger on the transistor, it actually gets very, very hot. What's happening there is you've got a lot of current flowing through the base emitter junction, and it's not pushing any current to the LED. So we remove that and we replace this. Instead of just having a jumper, we have a pull-up resistor which limits the amount of current flowing into the base and pushes some current through the LED. Here is a cheapy voltmeter, and we're just going to set it onto a volts range. So the grey wire we're going to connect to the minus power rail, the 0 volt section, and we're going to put this connector wire here into the same row as the base. When I touch this switch, you'll see that the voltage shot up to 0.78 volts. Let's have a look, see what happens if we replace the 1K resistor at that point with the 10K resistor at that point. Notice how the voltage only went up to 0.71. The LED did come on brightly, but the base didn't go up all the way to 9 volts. And this is ostensibly a 9 volt battery, but maybe it's only putting out 8 volts. We can quickly test what voltage it's putting out by connecting this into the power rail. This battery is slightly discharged, but still good enough for these experiments. So we've put our 10 kilo ohm pull up resistor there, push the push button switch, and you can see the voltage on the base is clamped to 0.71 or thereabouts. This is a light dependent resistor. I'm going to put the LDR between the base and the emitter. Here the LDR is in darkness, but when I move the cell phone torch, the LED switches off. So effectively what you're seeing there is a day-night switch. When the LED is on, you've got 0.7 volts on the base of the transistor. So now we have light on the LDR, and notice how the LED over there extinguishes at about that point, and notice how the voltage on the base has dropped to 0.48 volts. As the light on the LDR intensifies, the voltage drops down, drops away, the LED extinguishes, and the voltage on the base drops. So effectively, this is an automatic system or an autonomous system that wouldn't require human intervention. So as the sun goes down, notice how the camera has got its own wonderful auto exposure system, so things is getting light and dark according to the camera's own exposure metering system. But as we get light onto the LDR, the LED extinguishes, and as the light goes off the LDR, the light comes on. We're just going to connect the LDR to the multi-tester, and we're going to go to the 200 kilo ohm range. And now what we're going to do is we're going to shine our cell phone torchlight onto the LDR. As we shine the light onto the LDR, notice how the value is dropping quite dramatically. So you see that's 1.2 kilo ohms. Let's go here to the 200k range. Now if I was to put the light right near the LDR, so we've got the meter on the 2000 ohm range, so we've got the resistance all the way down to 240 ohms, which is pretty low. It's 8 kilo ohms, 9 kilo ohms. So now we increase the range, and you'll see the range has gone to 25 kilo ohms. And if we switch off one of the room lights, 40 kilo ohms. If we cover the LDR, it goes off the range again, so that means it's above 200 kilo ohms. If we put our finger over there, it's gone above the range, so that means it's more than 200 kilo ohms. So we go up to the 2000 kilo ohm range. Even there, it's gone right off the range, so that means it's more than 2 mega ohms in the dark. 300 kilo ohms, 450 kilo ohms, 680, 700 kilo ohms, 800 kilo ohms, 900 kilo ohms, 1 mega ohm, 1.4 mega ohms, 1.6 mega ohms. Here we've got our 9-volt battery connected there. That's our pull up switch, pull up resistor, and a pull down resistor, 10 kilo ohms, down to ground or 0 volts or earth. The emitter connects down to ground or 0 volts, and the collector connects to a light emitting diode with a current limiting resistor to 9 volts as well. Now, there is our transistor. So if we have a 10 kilo ohm resistor pulling down, maybe we've got infinite resistance pulling up. So this LED would be off because the base is connecting down to 0 volts. So we've got 0 volts over there, 9 volts over here. When we press the push button switch, the back of the push button switch, we've got a line like this. We've got these 2 pins looking at the back. These are permanently connected. It's only when we push the push button switch that the circuit is closed between these pins, which is basically like that. Now, if we've got a 1 kilo ohm or other kilo ohm resistor here, then it's going to pull up to the 9 volt rail. But the clamping action of the diode action of the base emitter junction looks like a diode, so it's only going to go up to 0.7 volts or thereabouts. So now we can get rid of that. And when that happens, this closes and the switch comes on, and the LED lights up. That's our emitter, that's our collector, that's the base. So B, C, and E. Then the emitter goes down to earth or ground, or 0 volts, ground. Then the base is connecting to an interesting little device called an LDR, which looks something like that. And on the other side of the LDR, we've got our connection to earth or ground, or 0 volts, 0 volts or ground. Then we've got a pull-up resistor here, connecting to 9 volts. And then from the collector, we've got our LED going to a current limiting resistor, going up to 9 volts. There's our transistor. Quite difficult to draw a nice round circle. There's our transistor. This is our pull-up resistor. This is our pull-down resistor. And the pull-down resistor is a LDR, which is a light-dependent resistor. The more light that falls on this item, the lower its internal resistance. When a lot of light is striking the LDR, the resistance goes very low. So this is light. The resistance goes low. When the resistance here goes low, it pulls the base through the lower resistance down to 0 volts. So you get 0 volts there. Now, once it starts to get dark, the light striking the LDR is less. There's less energy acting on the LDR, and the resistance goes up to very high in the kilo ohms. When the resistance here increases, this pull-up resistor, which might be a 10 kilo ohm resistor, is now the lower value of resistance. So now, when it's dark and this resistance has gone very high, then this pull-up resistor, even though the resistance value here is pretty big, becomes the path of least resistance. And then what happens is, at the base, the resistance starts to be pulled up to 9 volts, and when it reaches 0.7 volts at the base over here, 0.7 volts, the transistor switches on, folks. The LED comes on and starts to make some light, but it doesn't go all the way up to 9 volts because of the clamping action of the base emitter junction, which operates a little bit like a diode. Thank you very much for watching this video. If this sort of thing interests you, then why not have a look at www.robotscience.co.za.